Welcome to the lesson on probability. All right, so probability, so in general, it's just the chance of something happening. Okay, so we are going to be looking at, where we actually run an experiment and, the chance of getting certain things to happen in that experiment. And then we're also going to look at theoretical probability in the sense that in a perfect world, if everyone has a chance of winning, or every side of the die has a chance of rolling out and all the stuff and picking a certain card. If everything has got an equal chance of happening in a perfect world, we're going to look at the theoretical probability of being able to get certain things, certain results. Okay. All right. So we're going to start off with experimental probability. So this is where, you're rolling flipping a coin, rolling a die, and, stuff happens sometimes. If you don't throw the, if you throw the die a certain way, you might have a better chance of rolling a certain number. If you flip a coin, not evenly, by accident, same thing, you might end up with more tails than heads and so forth. Okay. So we're just looking at, just kind of what could happen in general when we're running an experiment. So we're looking at finding the probability of things happening. So P is for probability, and then we'll put in here the event. So it might be the probability of rolling a 4, probability of rolling a 1 on this die here. And then so basically we're going to write the number of successful trials, so how many times we were able to roll the 1, and then how many tries that we tried to roll the die. So if we rolled it like 50 times, how many times did we roll a 1? We'd go up here, and then 50 would go down there. Okay. And then when I say die, we call one of these a die. If we're talking about more than one, it's dice. We say we're rolling dice, so then we're rolling more than one. But if we're rolling just one, we call it a die, rolling a die. Okay. All right. So here we ran an experiment. Okay. So we rolled the die so if we're counting out, we rolled it 20 times. Okay. So out of the 20 times that we rolled it, these are the statistics that we found. We found that a 1 rolled 4 times. Okay. A 2 rolled 3 times. So see how the bar graph works here? 1 time, 5 times, 3 times, and 4 times. Okay, so this is what we found in our experiment. Okay, so, and again, if we're looking at theoretical probability, if we were to roll this die 20 times, they would all equally have an equal chance of being rolled. Okay, so let's say, like if I say 24 times. So if we roll it 24 times, then each of these would roll 4 times each. Okay, so the bar graph would be straight across. But this is an experiment. Stuff happens. We might not roll it the same way. It might tumble more times than other times, and you might end up with like rolling a 4 the most. Okay, and then rolling a 3. And then the next day you do the experiment, these results can be completely different. So, all right. So for now, I just want you to go through. Can you read this graph and tell me how many times did you roll a 5? Okay, so we're looking here. We rolled a 5 3 times. Okay, so 3. All right, and then I want you to find the experimental probability of rolling a 6. So again, remember P. So this P here represents probability, right? Okay, so if I say probability of rolling a 6, experimental probability, so then you could just write probability is 6 like that, or if you want to write roll 6, whatever you want there. Okay, so probability of rolling a 6. So if you're looking here, so what you're going to do when you write probability, because here you just told me how many times you rolled a 5, right? But here I want you to tell me the probability. So you have to tell me how many times did you roll a 6, and then how many trials did you have? So how many rolls did you have altogether? So again, if we count here for 4, okay, that's 8, and then we have 3 and 3, that's 6, that's 14. Then we have 15 here, and then 5 more is 20. Okay, so total rolls that we made was 20. Okay, so out of the total rolls of 20, how many times did we roll a 6? Well, if we look here, 4 times. Okay, so there's our fraction to represent our probability of rolling a 6. We want to write it in our lowest terms, so just divide out. So 4 and 20, what can you divide out of both of those? A 4, so then 1 over 5. So there's your fraction form. I also want you to write this as a decimal. So all you're going to do is go 1 divided by 5. And if you do that, you will get 0.2. Okay, so there's your decimal form. All right, and as a percent, you're just going to multiply this decimal by 100. Okay, so then you get 20%. All right, so there's your percent. All right, so be able to report the probability in all three forms, okay? Let's back up. Okay, so just a reminder, so you know how to get to the fraction using the equation, but then if you want to get to the decimal, all you're going to do is you're going to take the numerator, which is the top number of the fraction, and you're going to divide by the denominator. Okay, and then if you want to get to the percent, you're just going to take your decimal and multiply by 100. Okay, and then you just write percent on as the unit. Okay, all right, so now that we've reported our probability as those three terms, from here on you can leave it as a fraction, it's okay, but just be prepared to report it all the different ways. Okay, so here's the next one. We have C here. What's the probability of rolling of not rolling a 6? Okay, so basically not rolling a 6, not a 6. Okay, so what is that the same as? Well, that's the same as probability rolling a 1, a 2, a 3, a 4, and a 5. Okay, but not 6. So what are we noticing here? Well, if we look at the total possible rolls for 1, so again, 1 was 4, 2 was 3, this one was 1, this one was 5, and this one here was 3. So if we add them up, 8, 9, 12, so 16, okay? So 16 out of 20 rolls is not a 6 or is a 1, 2, 3, 4, 5 roll. Okay, and then we're going to reduce this, so divide them by 4 to get 4 over 5. Okay, so the probability of rolling not a 6 is 4 over 5. Okay, so from there, what do we notice about rolling a 6 and not rolling a 6? How are they related? Well, if you take rolling a 6, so if the probability of rolling a 6 is added to the probability of not rolling a 6, look what happens. So you take them 1 over 5 and 4 over 5. You add up the fractions, you get 5 over 5, which is 1. Okay, so if you take the probability of doing something and the probability of not doing something, it's opposite, and add them together, you'll always get a probability of 1. Okay, because it's like, think of it like if this is a probability, think of it as like, it's like the same as writing it as 100%. Okay, you're thinking of all the possible outcomes here. So if we were to add them up, it adds up to 100% of all the outcomes. So that's how they're related. Okay, so so just kind of be able to think kind of this way as well, where you're thinking of when it's not 6, what is it? Oh, it's all of the other numbers. If it is 6, then you just go grab the 6. Okay, all right. So that's what you do with the experimental probability. So what's going to happen is, if you ran your own experiments and collected data, you're going to find that, stuff happens so that you don't get an even outcome of all of the different rolls, right? So here, like 4, for some reason, there were lots of rolls, but 3, there weren't, okay? So that's just what happens just in an experiment. But now we're going to move on to theoretical probability. And this is where we are just looking at, well, we're just going to assume that every roll that we make, every time we pick something, it's going to be perfect in a perfect world so that everything has a chance of happening equally, okay? So this is what they call theoretical probability. So all the outcomes are equally likely, okay? They all have the equal chance. There's no, there's not, one side of the coin is not going to, flipped more than the other, okay? It's going to be equal. So Okay, so here's a new probability equation. It's similar to the experimental one. So the probability of a specific event happening. So what you're going to do here is, again, you're going to write the number of successful outcomes. So in a perfect world, this is how many times you should see, heads or tails, okay? And this, the bottom is still the total number of outcomes, okay? All right, so here is a coin toss. So basically, if we're tossing a coin, it doesn't even matter how many times we do this. We should always get the same probability, okay? So what you're going to do here is okay, so for the first one, you have the probability of tossing heads, okay? So again, if the, the coin has the queen on it, okay? So oh boy. Okay, so if that's the heads part, okay, the queen. And the tail is usually the animal or boat or whatever is on the other side, okay? So that's how this works, okay? Some of you might be rolling your eyes like, I know what heads and tails are, but I always find every year there's problems, okay? So again, this could be the boat, it could be the, on the dime. There's the beaver on the nickel. There's the loon. There's the bear on the toonie, okay? We don't have a penny anymore. Oh, quarter. What's in the quarter? Caribou. Caribou? Yeah, I think it's caribou. So anyway, so those are considered to be the tails. I know they're not actual tails of things. Some of them have tails, but or maybe they all do have. Well, the boat doesn't have a tail. Anyway, so that's the tail part. The head is where the queen is, okay? So if you're tossing a coin, the probability of tossing heads, okay, is, well, how many, like if we have just one coin, if we have one coin, how many heads are there in a coin? Well, there's only one queen, right? And then the bottom, the total number of outcomes, well, there's two outcomes. There's heads or there's tails. So there's two different things that you could get. So that's why we write 2 at the bottom here. Okay, so the probability of tossing heads is 1 at 1 over 2. Okay, so if we did it the other way as well, what's the probability of, tossing tails? Well, same thing. How many tails are there on the one coin that you have? 1. And how many possible things could you get when you flip a coin? Well, you can get heads or you can get tails. So there's 2 things that you could get. So that's what you write at the bottom there, okay? All right, so that's coin toss. All right, so now let's move on to rolling a die, okay? So I've already talked about how 1 is a die. If you're talking about more than 1, it's dice, okay? So again, if you aren't familiar with a die, there's one side has 1, okay, another side has 2 dots, another side has 3 dots, 4 dots, 5, and 6. Okay, so yeah, there's 6 sides, and these are all the different sides of the die, okay? All right, so if you had the 6-sided die and you roll it, what's the probability of rolling a 4, okay? Okay, so last time when we were looking at experimental probability, we were looking at a graph and, we could read off some numbers and so forth, okay? So all you're doing here, we're looking at a perfect world. How many 4s are there on this die? Okay, so these are all the sides. There's only one 4. So you're going to write 1. That's the probability of rolling a 4. That's how many of those are. Well, how many different possibilities do you have when you roll a die? Well, there's 1, 2, 3, 4, 5, 6 sides that could end up rolling up, okay? So that's what you write at the bottom. So the bottom is, not the total like last time, but it's more like how many possible outcomes are there. So you need to add them all up. 6 possible outcomes here. A coin only has 2 possible outcomes, okay? All right, so yeah, so 1 out of 6 of rolling a 4. Okay, so then what is the probability of rolling an even number? Okay, so then we have, so again, hopefully that's, you understand the even numbers. Okay, so even numbers are 2, 4, 6, right? 8, 10, 12. So on a die though, there's only a 2, a 4, and a 6. Okay, so what's the probability of rolling an even number? Well, how many even numbers are there on all these sides? There's 3 even numbers. How many possible things can, roll up? There's 6 possible sides that could come up, right? So still the bottom number here is 6, but then you want to reduce it. Okay, so divide them both by 3 and you get 1 over 2. All right, and last one before we move to cards. What is the probability of ruling a number greater than 4? Okay, so probably greater than 4. Okay, so what does that mean? Greater than 4. All right, so greater than 4. If it's greater than 4, do you include 4? Okay, no. Okay, so it's 5 or 6. Okay, so just kind of watch out for the wording of these ones. So if it's greater than 4, that means only 5 and 6. That's what we're looking at. Okay, so how many 5s and 6s are there? Well, there's only 2. And how many possible sides are there? 6. Right, so the probability of rolling a 5 and 6, when you divide it and reduce it down, is 1 over 3. Okay, all right, so we've gone through the coin toss, rolling a die. Now we're going to move to cards. Okay, so again, just if you really know what cards are and what, all the terminology, awesome, okay? Again, there's some students that they haven't really gotten to use cards, so they don't really know the lingo and the terminology. So I'm just going to go through that. Just be patient, everyone else. Okay, so we're going to start off with suits. Okay, so they call it a deck of cards. So the whole pile of cards is called a deck. Okay, they have suits. Okay, so 4 suits. So if you think of it, it's just the different patterns, I guess, that you see there. So suits, that just means, you got the hearts, you got the diamonds, you got something that looks like this, which I'll explain what that is in a sec. Okay, and then there's this one here. It looks like a clover. Okay. All right, so those are the suits. There's 4 of them. Okay, so there's 4 suits. All right, so so this one here, looks like this. Okay, so it kind of looks like a leaf, I guess. They call these the spades. Okay, so I guess like there's a shovel that you can use in your garden that they call a spade as well, so spades. All right, these ones are the diamonds. Okay, and diamonds are always red, so I guess I should have colored it in red. Okay, and then the spades are always black, I guess. I don't know why I'm calling it. Okay, then there's clubs. Okay, so looks like a clover to me. I don't know. So anyway, I should stop coloring these in. So they're always black, and these are called the clubs. Okay, and you guys can look up how these names came about, I guess. But these are the hearts. Okay, they're always red. All right, so you have your 4 suits. Okay, so I might ask you things like how many spades are there in the deck, or what's the probability of getting a spade? So you need to know what spade is, or club. Okay, so the black ones that look like clovers, but you say clubs. And then there's diamonds and there's hearts. Okay, all right, but altogether, if you count them all up, there's 52 cards altogether, but there's 13 of every suit. So if you go aces, think of it as like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then it goes Jack, Queen, King, okay? So J is Jack. J is Jack. Okay, Q is Queen. And K is King. Okay, so Jack, Queen, King, and all together you add up all those, and that's 13 in each suit, okay? All right, what else do I have to show you? Oh, sometimes they'll say face cards. Face cards? Like how many face cards do you have? Okay, so if you have a face card, it means you have a face on your card. So if you actually look at these cards, there's the actual person and then there's another person on the other side. Like it's not symmetric, I guess, but it's like part of half the top of a person and then top of another person on the other side. So anyway, these are all the face cards. Okay, so if you have a face on it, a Jack, queen, king, or the face cards. Okay, so ace isn't one, two, three. These aren't one. Okay, but these are the face cards. All right. So now that you know the terminology, hopefully we can go through and look at the probability. So if I mix this deck of cards really nicely and evenly, I want you to like pick out something. So like I'm gonna for the first one, I'll say, what's the probability of picking out a card that has hearts on it? Okay, so you need to write the probability of that happening. Okay, so let's start with that. So we always write P for probability. The event is, picking a heart, all right? So what's the chance that you're going to pick a heart out of this pile of 52 cards here that are all mixed up evenly and they're turned over so you can't see what's on, like what card you're picking, okay? So yeah, like again, if you flip over the cards, it just has this pattern that they all have. And so when they're flipped over, you don't know what card you have or you're picking, okay? All right, so what's the probability of picking a heart out of this pile of cards? Well, how many hearts are there? Okay, so you're looking here, diamonds, clubs, spades, no, hearts, okay? So that's a suit. Remember, there's 13 in a suit. Okay, so there's 13 hearts in this pile. How many are there altogether in this whole pile or this deck of cards? 52. Okay, so 52 is that number that goes there. All right, and if you try to reduce 52 and 13, they actually reduce really nicely. You can divide a 13 out of both, and you get 1/4. Okay, so that kind of makes sense. 1/4 chance of getting hearts. Okay, so give us some more space here. So now ace. Okay, I want you to figure out ace. What's the probability of picking out an ace? Okay, so again, did I tell you what an ace was? No, I guess I didn't. All right, so ace is that A card here. Okay, so we'll put it up here. A is ace. Okay, it's the ace card. Depending on what games you're playing, it can have a value of 1. Sometimes it can have a value higher than everything. So anyway, I'm not promoting gambling or anything, so just you can kind of explore on your own, I guess. So probability of an ace. Okay, what's the chance of you picking out an ace? And it doesn't tell you what color, it doesn't matter, right? It's just all the aces. So how many aces are there? Well, there's one here, one in that pile, and one in that suit as well. Okay, so there's 4 aces. But how many cards are there altogether? There's 52. So 4 out of 52 cards, okay? So again, if you want to try to reduce that one, yes, you can get it to reduce down, divide by 4, get it to 1/13. So I say the trickiest part today is probably just reducing the fraction, okay? So again, if you were wondering how I did that, I just divided, both of them by 13 here. And that's how I reduce it down. So I'm just looking for the biggest number. It's like greatest common factor, right? So I'm dividing a 4 out of both of these, okay? And then I'll get it to 1/13. All right, the next one. What is the probability of getting a heart? A club. What is the club? Oh, club is the clover one, right? Okay, and a jack. Okay, so you're looking at that and going, okay, what's the probability of a heart? Okay, well, how many hearts are there? Okay, so there's 13 hearts. How many clubs are there? There's 13 of those. And how many jacks are there? So there's a jack in every suit, right? So there's 4 of those. Okay, so now that we've figured that out, you're gonna now, because it doesn't matter which one, because it says this one, or this one. Okay, so okay, so so you know that you have 30. Like say you win if you pick one of these, right? So your chances, you have 30 that you could possibly pick out of how many? 52. Okay, so those are your odds. Okay, and you can divide this one by 2 and you get to there. Okay, try your best to reduce it. I'm not going to pick on you guys if you are having trouble, but you should be at this point where you could find that number that works. Okay, and in a rule of thumb you can use is that they're both even, you can divide a 2 out, right? If you see a 0 and a 5 at the end, I usually have 5 will work. But yeah, just try your best to reduce it down. But like 13 for these ones are going to happen a lot. Okay, so you can try to grab those often. All right, so but yeah, try to get this correct, and then try your best to reduce it down. All right, what is the probability of getting a black diamond? Okay, so you're like, okay, diamonds, where are they? Diamonds are all right here. Okay, so what's the probability of getting a black one? Well, like I said, these colors don't change. These ones, spades are always black, right? So here, if I color them in, clubs are always black. Okay, and hearts are always red. Diamonds are always red. So what is the probability of getting a black diamond? Okay, so if see how you don't see any black diamonds, you can't get any black diamonds. So what's the possible outcome there? 0 out of how many cards? 52. So what's the probability of getting a black diamond? 0. It's not going to happen. Okay, so just kind of go through and think your way through these and go, oh wait, that doesn't make sense. Okay, so 0 out of 52. All right, last one, right? Before we move to the next one. What is the probability of getting a heart, a club, club, which is the clover, club, a spade, and or a diamond? Okay, so basically you're going to go through, this card is all mixed up. So yeah, I know you picked out all these cards above here, but you've always put them back. So we're starting fresh again. Okay, so this deck is mixed nicely, perfectly. And now you're going to pick out one of these cards. Okay, so what's the probability of picking a heart, a club, a spade, or diamond? Okay, so basically um, there's 13 of those, 13 of those, 13, right? So you know there's 13 of these, 13 of those, 13 of those, 13 of those. So altogether, there's 52 of those, okay? But how many cards are there? 52. So basically, you win regardless of what card you pull out. So this reduces down to 1. Your probability is 1. And again, if you change this to a percent, your probability of getting one of these is 100%. You are going to win. Okay, we're back here. If you wanted to change this one to a decimal, this becomes, 0.1 or 0.58. So if you make that into a percent, the percent of the chance that you will get a heart, a club, or a jack is 58%. Okay, so still okay odds, but this one here, you win regardless. Okay, so it doesn't matter what card you pick out. If you pick out one of these, well, there's 52 chances of picking them out of 52. So you have a 100% chance of winning. Okay, so that's why with these probabilities, it's, you can get them to your fraction easily, but then, usually going to a percentage is just kind of helps you understand probably a bit better, just because you're used to seeing things in percentages and so forth. Okay, so yeah, so that's why you can do too on the side, is calculate some of these out to decimals and then to percents. Okay. Okay, so we're just going to stop there. So I just wanted to teach you about the cards and the die and the coin and so forth. Yeah, so just I want you to go and practice, writing out the probability statements here, being able to write them as a fraction, as a reduced fraction, but also being able to write them as a decimal and a percentage as well. Okay. All right. So once you feel comfortable with, using the cards and the die and so forth, I want you to go and try the checkpoint. But so again, just review this. I know it's okay if you don't, if you didn't know, the names of all these different card pieces and so forth and so forth. Okay. It happens every year. A lot of people, the parents say they're not allowed to play cards. So, so yeah, so just kind of review this and then tackle these questions here.